Hi, in the last video we learned how to conduct hypothesis testing for the two dependent sample means, and for this section we learned how to use the Fisher's or the F-test for testing the claims made about the two population variances or the standard deviations. So consider again we have the population 1 and the population 2. S1 square represent for the sample 1 variance, and S2 square represent for the sample 2 variance, and 1 is a sample size for population 1 and 2 is a sample size for sample 1. And the sigma 1 square, this is the population 1 variance, and the sigma 2 square, this is the population 2 variance. And before we can use the F-test, make sure we check all the requirements. The first one is when the two populations are independent. Independent means when I pick a data for sample 1 and then I pick the data for the sample 2, it doesn't affect how I choose the second data for the sample 2. If I after I get the data for sample 1, and then the two samples are simple random sample, and make sure that each of the two populations must be normally distributed regardless of their sample size. This is a strict requirement, so I don't care what is the sample size for N1, what is the sample size for N2. Each of them must come from the population that is normally distributed, and we can use the histogram or the normal quantile plots to check for that. The F distributions so we assume that the population 1 variance and the population 2 variance, they are the same, they are equal. And then all you do to find the F distribution is to take the ratio between the sample 1 variance and the sample 2 variance. And the degree of freedom on the top is for the sample 1, so N1 minus 1. And the degree of freedom for the bottom is N2 minus 2, right? And please note that the F distribution only take the positive value, so 0 and greater than 0. So nothing for negative, okay? It's only 0 or bigger. And then the F distribution is not symmetric, so this is skewed to the right. So because this is not symmetric, you cannot just find the p-value for the two tails by finding one right tail and then multiply it by 2 as before. So that is not easy as before in this case, because the F distribution is not symmetric. And when we get the value for the big F here near 1, that means the two sample variances are almost equal. So if you get the value close to 1, that is the evidence suggesting that the population 1 variance and the population 2 variance, they are the same. Now we can use the p-value method to test the claim. The first step is determine the null and alternative hypothesis in one of the three cases: left tail, right tail, or two tails, and select a level of significance, compute the test statistics, and then use the table A5 or technology FCDF. I highly recommend we use the technology, the function FCDF from the TI 83 or 84 to find the area under the curve, which is the p-value. So the function FCDF is take 4 inputs: the lower bound, the upper bound, the degree of freedom from the numerator, and then the degree of freedom from the denominator from the second sample. The left tails, the right tail, the two tails is complicated, so we focus more on the left and the right tail for these sections. And if the p-value is less than alpha, we reject the null hypothesis. If p-value is bigger than alpha, we do not reject. Now we can do the same thing and use the critical values. In this case, again, all you do now is just find the critical value and then make sure that the test statistic is outside of the critical region. If it's inside the critical region, then we reject the null hypothesis. Okay, let's consider this example. A researcher wanted to know whether the state quarter has a standard deviation weight that is less than the traditional. Less than here, this is the claim. Less than means the left tail, right? The left tail, less than. Okay, so he randomly selected 18 state quarters and 16 traditional quarters, weighted each of them, and then obtained the following data. A normal quantile plot indicates that the sample data could come from a population that is normal. And thus the researcher claimed that at the level of significant alpha equals 0.05, now we know that there are 18 data for sample 1 and 16 data for sample 2. So N1 is 18 and N2 is 16. We check the requirement. The two populations are independent, yes, because when I pick the value for the state quarter, it doesn't affect how I pick the value for the traditional quarter. And the two sample size, the two samples are simple random sample, yes, because he randomly selects the 18 state quarter and the traditional quarter. And the problem also gives us the information that the data comes from population that is normally distributed right here. Okay, so we missed our requirement. So now we can use the F test. To use the F test, go back to the F distribution. We need the sample 1 variance and the sample 2 variance, and then take the ratio. Now I have the two sample data, but I don't have the variance for sample 1 and sample 2. So the next step is I have to find that. Now I call the state quarter to be the population 1. I enter the data to the list A1. So I took off this data here. I go to TID4. I input that to the list A1. And then I just go to start calculate, use a 1 var start, and then just hit the calculate. And the S here is the standard deviation, or S1. And do the same thing. I store the data for the traditional quarters to the column L2, and then use the 1 var stats to find the statistic for that column, and it gives me the standard deviation to be at 0.0689. And we can find the statistic just to get the ratio of S1 squared and S2 squared. So make sure you square them and then take the ratio. And we know that this is the left tail case. So I label the F statistic here. And to find the p-values, we can use the FCDF. I just want to find the area under the curve. And you can use the FCDF. The lower bound is all the way to here. Actually, this should be 0, right? Because there's no value that is below 0 in theory for the F statistic. So you can change this, the lower one, to 0. So we start from 0. We go all the way up to the test statistic 0.05 to 3, and then the next one is the degree of freedom of sample 1, which is the one on the top, and then 18 data, subtract 1, and the bottom is the degree of freedom for the sample 2, which is the S2, which is 16 data points, subtract 1, and then you just find that the p-value is 0.0982, and this is greater than alpha, so we do not reject. Okay, so again, here the lower bound should be 0, but I use the negative infinity, but actually it should be 0 because you don't have any negative value for the F distribution, so it should be 0 here. And yeah, we don't have a function to find the inverse F distribution on the TI calculator, and therefore we won't focus on using the critical value method in this section, because in order for you to use the critical value, we have to be able to find the critical value given the alpha, and we don't have the functions installed in your TI calculator to help you to find the inverse F distribution. Therefore, we won't focus on using the critical value methods in this section. So the p-value is good enough. Now, because we do not reject the h0, that means we do not reject this guy. That means we cannot say that the state quarter is less than the traditional quarter. So we cannot support the other claim. Or there is insufficient evidence to conclude that the standard deviation of the weight is less for state quarters than it is for traditional quarter as a level of 0.05 significant level. Now, if you just want to use the TR83 or 84 plus to compute the p-value, you can do that very easy. The first is we enter the state quarters to the data list 1 as in the last example, right? And then we enter the traditional quarter to the data list 2 as in the last example. So we enter the list 1 for state quarter, list 2 L2 for the traditional quarter. And then you go to the start test. So make sure go to start and go to test, and then pick the 2 sample F test. We have 2 samples, so we go to 2 sample. This is Z, this is T, 2 sample F test, which is right here, option A, 2 sample F test. F stands for Fisher test. And then just enter that and make sure the input is data, right? Because you store the data to the list L1 and the list L2. So make sure that we have the list for sample 1 is L1, list sample 2 is L2. And in this case, the alternative hypothesis is L1 is less than L2. Sorry, sigma 1 is less than sigma L2. And then we hit the calculate. So it will give you the analysis here. The p-values right here 0.0971, and this is close to our last example, right? Okay, so we do end up with the same conclusion that we do not reject the h0 because the p-value is greater than the alpha, which is only 0.05. Okay, so that is the end for this section, and thanks for watching.